Okay, so we're going to look at an example where we're solving a polynomial inequality. This example, we're going to use 2x squared plus x, which is greater than 15. So kind of following our procedures, our steps, the first thing that you always want to do is get your function greater than or less than 0. So we're going to do this by subtracting 15 from both sides, which gives us 2x squared plus x minus 15 greater than 0. Once we get that, we want to solve the equation. Well, in order to solve the equation, we've got to make it an equation. So we're just going to replace the inequality sign with an equal sign. This particular problem can be factored, so we would want to factor it in order to solve it. So that gives us 2x minus 5 times x plus 3. And then remember, to solve it, you just take each factor, set it equal to 0, and find x. So the first factor, 2x minus 5, gives us an x value of 5 halves. And the second factor, x plus 3, gives us an x value of negative 3. These 2 points give us our boundary points, meaning that this is when x is equal to 0 in this function. Well, because our inequality sign is just greater than, we don't necessarily want to use these in our solution. Remember, they're just boundary points. So the next step that we want to do is go ahead and graph these on a number line. So here's my number line. Let's say this is negative 3, and this is 5 halves, or 2.5, whichever you prefer. So what this does is it creates 3 intervals that I need to test. The first interval would be negative infinity to negative 3, and remember, we're not including it because it wasn't an equal to inequality sign. The second interval would be negative 3 to 5 halves. And then, of course, the third one would be from 5 halves to positive infinity. So what we want to do is test a point in each interval to figure out whether it is a true statement for our inequality or a false statement, or a positive answer and negative answers. Positive answers are going to be when our number is greater than 0. A negative answer would be when the solution to our test value is less than 0. So, for example, let's go ahead and test for the first interval, negative 4. So when I do that, I'm going to plug it into my original function, 2x squared plus x minus 15. Plugging it in, I get an answer of 13. Well, 13 is greater than 0. So for this interval, I would have a positive answer. Again, testing another point from the second one. Let's test 0. Again, it goes right into that original function that we started out with. So I'm just plugging in 0 this time for the x value. And I get negative 15. So for this interval, I have a negative answer. And then the last interval, we can test three. And once again, going back to my original function, plugging 3 in for the x this time, I get an answer of 6, which is positive, a number greater than 0. So again, you remember from the beginning, and I'll go back here, this inequality is greater than. So I want all the values, the x values, that have positive answers. So go back to your graph, and you notice the interval from negative infinity to negative 3 had a positive answer, and the interval from 5 halves to positive infinity had a positive answer. So this is the intervals that I want to choose to be my solutions to this inequality. So we're going to write our solution in interval notation. So it's going to go from negative infinity to negative 3, unioned with 5 halves to positive infinity. And that's it.